God, like I am able to share and you are able to listen again. So in last time, like I covered the chapter 2.2.4, which is string in Swift briefly. So now I have one more topic and I'm just covering rest of the data types and logical value. So numeric and logical values I'm just covering here. Section 2's 2.2.5 data type numeric, int, double, float and logical bool value, right? So first number 1.1 is saying sign integer. Inside the sign integer, what is the sign integer? That means it will hold the negative value as well, right? So there is a 5 types: int, int 8, 16, 32 and 64. Now NSInteger, what is this NSInteger? It is a type alias of int only. So I'll take this one first into our Xcode playground. We'll check what is the value and everything. If you will go there and we'll create this blank page, and it can be a numeric and logical values or data types DT. So now if you will go there and check it out, this one, what are the sign integer, that I'll explain you. So sign integer is nothing but, like, if I will go and just proceed with integer, this int, so let int value, and I can just give a int max value, and it can be int max. And if I can just proceed and just type int min value, and it can be a min value. Same like that, I can just type all the things: int max, int 8, and this int 8 also I require int 16, and here also I want 16, and this one is 32. So then finally I have 64, and this one is also 64. So these are the values that I need to change. So I'll take int 32 and int 16 can be there, yeah, and int 8 can be there, and normal int will be there, and int 64 will be there. Then I need to print those values, or I can run like this only. So the values will be here. If I will run whole thing, it's running. The value is like that. So if you will see, this is the value of int. Now if I want to print the NSInteger value, then what will happen? That also I need to check. So redeclaration int NSInt, so that you should be not confused in any case. That is my motto of the data types. Like, can you see the same value they are giving? So as I told you, like if you will go and jump on this, you will see the integer is the mother of this NS integer, right? So in the Objective-C they change this, and it is a NSInteger with the int, and the value is same. So what you need to understand, like if it will run on 32-bit processor, then it will convert like that. If otherwise, like it will be equivalent to 64. So that is the meaning of int. It's independent. So whatever environment will be there, it will change its value with 64 or with 32. Right now 64 is running, so this value and this value is equivalent, right? If 32 will be there, then this will be equivalent to 2147. the integer one, right? So the int is independent, and corresponding to the environment it will change. So it is saying on a 32-bit platform int is the same size as int 32. On a 64-bit platform int is the same size as the int 64, right? Now what is an unsigned integer that I want to tell you? These are the value. Int 8 is very smallest, 127 to 128. Then bigger one is 32767 and minus same value, and the 32 will be more larger, and the last one will be int 64. Same like that, unsigned integers are there. So rather than negative value, minus value, they will work in positive only. So from 0 they will start, and they will u unsigned, so they will just relate to u, and you can make the u, and it will work like that only. And NSInteger is okay, but NSUI integer will not there, so it can give you error. So it will be not there. I think it will be not there, cannot found NSUI integer, so you can remove this one. And there is a 1, 2, 3, 4 and 5 things you need to print, and the u you need to make in front of each and every type of integer. So now quickly you will print those values, you will get the result, and you will understand what range and what things are there, right? So once you will print those values, like UIint max value is 18 something like that, and the minimum is 0. Minimum is 0, max is 255 for the UInt unsigned int 8, and for the max value of 16, 650, and this one is 32, and this one is 64. So same here, like it's a environment is right now running into the 64, so UIint will be just equivalent to UIint 64, and that is proved. Here it's a 64, and this is also 64. It will be the environment, OS environment will be the 32-bit, then it will be equivalent to 32, right? So that we understood like what is sign and unsigned. Sign will always go with the negative value, unsigned will go with the always 0 to positive value only, right? So now if I want to increase, if I want to give some value to UInt max value as a, if I want to change this into 5, then it can be changed, right? But lat is there, so I can convert into the var, and suppose I'm changing this var into the positive value, it will change. But what will happen if I will give unsigned value as a negative value, then it will give you error. Negative integer 4 overflow when stored its property, right? Unsigned type UIint. So what you need to do, you need to make this as a int, and then you can just give the minus negative value, right? Keep in mind. So if you want some positive value, then you can just always use unsigned int, right? So suppose one more thing I want to tell you here, what is a type alias? So type alias will be a keyword which will type convert a name, convert a syntax into a different name, right? So I'm just giving you example of audio value, and it will be always 0 to positive value. Then you can just make UI int, and the min value UInt uint will be min value, and this min value will be audio value, which I will set over there into my variable means audio value, and this will be a audio value. Then if I want to change the audio value somewhere, then I need to change, I need to plus some value like 2 something like that, then it can increase. If I will give negative value over there, then it will not work, right? so then it will not work, right? So audio value, if I want to give audio value as a minimum value now, then it will give me 0, and once I'll plus this, it will give me some plus value also, right? But if I will give some -5 value or -2 value, then it will tell me, hey, don't go beyond the 0, right? Because it's a unsigned integer, right? It's an unsigned integer, so you can't go behind the 0. That's all you need to take, right? To understand, you need to understand like negative integer -2 overflow when stored into unsigned type audio value, that you need to take care. Now the last thing is for the integer, like integers are, int is allowing the binary, octal and hexal representation as well. Okay, so how you can just use them, what are the binary and octal and hexadecimal things that you can quickly check. So if you will go and check this thing here, so you will see like this is my number, like 0 to 15. If I will consider, this is my denary number, that means decimal number, 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 till number. So hexadecimal is saying it will be with the base 16, it will be loaded with the base 16, it will be loaded with the base 8, it will be loaded with the 2 only, 0 or 1. So if you will go, 0 value will always be 0, 1 that means the initial 1 will be there, and in octal it will be 1, and hexa it will be 1, 2 2, and the 2 goes like that, and the 2 will come from here to here, 1 it will be 2, and 3 is 2 plus 1 3, 4 will go one more further, 4 will be here, and 4 will directly come here, like that. So hexadecimal values will go till 9 to 9, and then further they will convert into F15, right? So in future, like 16 will be the value, then they will convert first value as a 0 and another will be 1, right? Like that they can proceed, and so on. Here also it will be work same like in octal, values will change 0 to 7, 8 values will be there, in between they will change the values, and corresponding to so on things will go there, and you will see 255 will be the last one, the combination of hexa, octal and binary, and at the end they will get the full value. So this is whole thing with the hexa and octa and base. So what Swift decided to move further with those values, with you need to suppose represent a value, and that value is over there as a, if you want to represent the 4 so or 10, then you will represent like that, and the value will come look like that. If you want to see the value, I will just declare here if my values I need to declare like let binary value. If I want binary value, then how it will be look like if I want to see the binary value of 4, then 4 is looking like this one, right? So how I can just write this, like binary will be the 0b, right? So I can just place this 0b here, and what I need to see, that I can see it will be the 4, not like that. So you can just do these values like that as well. Then octal is there, octal value of 4, how I need to change, octal is 004, right? So I can just change this with a number of 0 0, and octal O will represent the octal value, and 004, then it will give me the same 4, and at the end hexa will do the same thing, hex value, and this value will be 0x, which will represent hex, and the hexadecimal value have 4, and this 4 is look like that only, and it will be 4, and value will be always integer 4. So it's like that, right? So if you have 15 value, then you can just place F, or 10 value, then 15 value, if I will place F, and for this I will place 17, and for the rest thing, like I'll check what is the exact value, this value. If I will place this one here after B, and if I will run this, like that, then it will be the 15, right? So like that you can just proceed and check it out. Your binary, octal and hexa, they will produce its integer result as well, and you can represent your hexadecimal and binary and octa values, and you can compare those values with the integer. Now the last thing I want to tell you, like float. What is the float? So float magnitude, I want to tell you like how it will work here in Swift. Float values will be there, same like upper top things. I need to check the magnitude of this, then I can go with the float greater values, greatest finite magnitude, and the least finite magnitude. The same like that, I can just go with some float 16 will be there, and then float 32 will be there, that will be 32, and after then I can just proceed float 64, that can be float 64, and float 80 like this only, and finally it will be a CGFloat. So CGFloat also I'll cover, don't worry about errors, I'll change those errors as well. And then I'm sorry, float will go like that. So it's overall like all about the float, integer, and sign, unsigned integer we changed and we covered it up, nothing more than that. So whatever numeric values will be there, those will look like this only, and this depends on you, like how you are just using those things into Swift, and you are just checking out all the least and final values, and these are float, right? So 16, number 16, so this is a float value, so this is a float value, this is a float value, and this is a 16 float value. So we can just go like that, and here float 32 is available, then float 64 will be there. Always your variable should be start with the small letter, that you should keep in mind, but for right now we are just copy pasting, and because of this we are just making this first letter as a capital letter, and that is not a good practice. So you can just immediately change this as well, because nothing will come further, like whatever you are writing, that should be changed immediately and things should be perfect, right? So now if you will see, all the values are in front of you. So float max, greater finite magnitude, and the least will be just equivalent to your CGFloat, say to your what value I am just assigning it, 3.4 and 1.1. Can you see the float 32? So right now it's taking float 32, that means float 32 is, I think, a float value, yeah. And if it will go with a 64-bit, then 64 will convert like that. So your float value will appropriately go with the processor values. So float is independent, however the environment will be there, it will change accordingly into the 32-bit or 64-bit, right? So you have the 64-bit value as well as you have the 32-bit and 16-bit, and this one as float normal value, which is just dependent on the OS level. So it will convert into the double value once it will go for the 64 environment, and it will convert into the double thing, because if I will jump over there, it will see, you will see the double type is there. So now AT and CGFloat is also you covered. CGFloat is nothing, it's a double. So once you will go there, it's a double, right? So the double, the last and least double. So double is a maximum number, and this is a max value. If you want so many decimals after your float, then you can use double, right? So double double will give you the power of maximum number of decimal points, right? So you can write the maximum number of decimal points, that also with a limit, minimum and maximum limit, which is here e plus 308, that means 10 to the power 308, which is very big number. So more than that, I think nothing will be there. So you cover the double, float, integer sign, unsigned values, and the binary things, that hopefully you understood. Apart from this, nothing else as a numeric values. So that everything you covered here. Now finally, one is a logical syntax useful value on declaration, which is bool. We all know about the bool. It's giving you the true and false value. So where it will be like, suppose one more thing I want to tell you, suppose you are creating a let value, and this value is a 3.1 3.2 something like that, right? So 3.22 is there. Now if I want to check this value is double or value is float, that you need to look around, right? So value is double or value is float. So by default, what it will take, your type casting, the fantastic very clever typecasting is there into the Swift. They are typecasting with this value. So where they will go inside the double or they will go inside the float, that I need to check. So if you will see, by default the value will be considered as a double only, that you should remember. So whenever you will give value without any type, like I gave the type here, I will give the type like that, then it's fine. Otherwise, like it will give the by default value of double, right? So if I will give float, then it will go to the float. Otherwise, by default value will be double. So same like that, if I am just declaring, so double is a by default value from the side of Swift. If I am declaring a false result or I'm just assigning a Boolean variable and I'm giving no value over there, right? So here, like if I want to print the value, and if I will go there and check what is my value, so cannot use before initializing. So let keyword rather than let, I will use where, because let wants some value, as I explained in earlier classes. Yeah, so nil is there, value is nil, but suppose like I have nothing will be there and some value, I will look like it will look like that, then also it is Boolean is nil. But by default, if nothing will be there, then by default value will be false, right? That also depends on you. So this is a Boolean variable. If I'm just giving a value type false, then it will give me the false value, otherwise it will be a true value. And rather than giving optional and implicitly unwrapped optional, I will give a proper perfect value, which will assign with the value false. and whatever value you want to give, that will come with this value only, and you can just play around your conditions with this bool. So for this chapter, like, it's more than sufficient. So you covered the section 2.2.5 numeric and logical values. There you understood like what are the signed integer and unsigned integer. Those are with the positive values from 0 to more than positive values. How like int is working over there and UInt is working over there due to the environment of 32 and 64 bit. How values are changing, binary and octal and hexadecimal values into the integer, and the float, how many types of float, and what is the CGFloat. It's just equivalent to double, and float inside the environment, it will be work like 32 and 64 bit. And double, we know very well what are the double. By default Swift values are double if we are not giving the type and we are just giving values in decimal. And the Boolean variable is a logical value condition data type. So over there, like if you want to check the conditions, then you can use this Boolean. And the last thing I want to tell you that I forgot, so I will come here and suppose into the integer, like this integer, if I'm just going here, rather than where the first one, this one, rather than let, we are creating it where. And here also I'm just testing it. I don't want like that int, okay, and 0 value is there. Like I want a value like 10,533, right? So if I will print this, you will assume like it will give me error, but no, it will be work like 10533. So this fancy thing is added for from the side of Swift, so that you can just read your data properly. Like 10,533 is the amount or something like that, so it will ignore your this special symbol and it will give you the proper value, right? So that is the advanced thing, and rest things are completely clear. And there are lots of features inside these integer and float and all. If you will type dot and check advanced by bytes by distance to divisor and coding, there you can just play with your full power, whatever you require they'll give to you, and you can just play around, right? So same like that into the integer. If you will go there and check it out, like floating points. So suppose I have float min value and I want a square root, I'll get some square root of it, right? So this one, and like you can just see advanced by, and those functions are there, and you can just use them functions for your mathematics very nicely. Is nan means a bool value indicate whether the instance is nan, means not a number, right? If number will be not there, then it will give you a true result of is nan, right? Is normal, is sign nan, right? It's a sign, like it's sign or unsigned. It's a subnormal. Is zero, that means a Boolean value indicates whether its instance is equals to 0 or not. Magnitude, negate, replace this value with the additive inverse, right? Round figure, round value will be there. Sign, significant, those functions are there, so you can just use them, right? Rounded figure, rounded, right? Rounded values after the decimal, you can, if you want to round the values, those functions you can use, right? And in the double also same thing are there, double min. And if you will see, there are lots of functions, same like float and integer. Is less than, is nan, normal, sign, non, subnormal, 0, magnitude, negative, right? So these things are also here next down, rounded, square root and all, right? So these functions are there. So same like a string, you can just play around with the integer float and double and the Boolean variable, and things are crystal clear. Nothing is more than that into the Swift. And protocols are definitely there for numeric values and Boolean values, but like data types are over here. And congratulations that you understood this integer, float and double and bool things into the Swift. And in the next chapter, like, I'll start with a new fresh thing which I'll explain you in the next session, which will be a 2.2.6. That's all. So if you like this channel and like whatever I'm doing, I'm just creating it with full of my passion. So it is a junior iOS engineer course, and we are running into the section 2. I want to reach till section 14. So if you like it, please support, love and share this channel to your friends and family members. Thank you so much. Thanks a lot.